Look, something concerning is unfolding right now across Windows 11 systems worldwide. The reports coming in are the kind that make any computer user's blood run cold. Users are describing scenarios where they installed a routine Windows update, the system restarted as expected, and then their drives simply failed. Not slowed down, not misbehaving, failed. Systems refusing to boot because the operating system drive can't be found. Secondary drives disappearing entirely from the system. File system corruption requiring complete reinstallation. Boot loops indicating critical storage errors. And the common thread linking these incidents is a specific Windows update, KB5063878. The timing is too consistent to dismiss as coincidence. Users report functional systems before the update, failed drives after the update. But correlation isn't causation, and that's where this situation becomes complicated and concerning in equal measure. Is this update directly causing drive failures, fundamentally damaging hardware through software? Is it exposing pre-existing hardware problems that were teetering on the edge of failure? Is it introducing driver conflicts or firmware incompatibilities that make drives inaccessible even though they're physically fine? Or are we looking at a more complex interaction between update mechanisms, encryption systems, and storage controller firmware that creates cascading failures under specific conditions? The uncertainty is what makes this urgent. If KB5063878 is actively damaging drives, every system that installs it is at risk and the update should be avoided or rolled back immediately. If the update is merely exposing drives that were already failing, then the update is actually providing early warning of hardware problems that would have manifested catastrophically later. And if the issue is compatibility-based, affecting only certain hardware configurations, then there's a specific subset of users who need to take precautions while others are safe. But right now, with reports still coming in and Microsoft's response still developing, users face a decision with incomplete information. Install this update and potentially risk their drives, or skip it and miss security patches and bug fixes it contains. What makes this particularly alarming is that storage failure is the nightmare scenario in personal computing. Processor problems are annoying, memory issues cause crashes, network problems prevent connectivity. But drive failures mean potential data loss, the permanent destruction of files you cannot replace. Photos, documents, work projects, personal records, everything stored locally is at risk when drive stability is compromised. And unlike other component failures that announce themselves gradually, drive failures can be sudden and catastrophic, going from perfectly functional to completely dead without warning. So when users start reporting that a Windows update correlates with drive failures, the stakes are immediately higher than almost any other update-related problem. To understand what's happening, we first need to understand what KB5063878 actually is and what it's designed to do. KB5063878 is a cumulative update for Windows 11, part of Microsoft's continuous update cycle that delivers security patches, bug fixes, performance improvements, and feature updates bundled together. Cumulative updates include everything from previous updates, meaning installing KB5063878 gives you all fixes from earlier updates, plus the new changes introduced in this specific package. This approach ensures systems are fully patched even if they've missed previous updates, but it also means each cumulative update is large and touches many system components. The update cycle for Windows 11 involves monthly releases on Patch Tuesday, the second Tuesday of each month, along with out-of-band updates released when critical security issues need immediate patching. KB5063878 appears to be a significant cumulative update that includes modifications to core system components, driver updates for various hardware categories, security fixes for recently discovered vulnerabilities, and improvements to system services and background processes. The exact changelog Microsoft provides publicly is often vague, listing general categories of fixes without detailed technical specifics about every change. Storage-related improvements are frequently included in Windows updates, and this is where potential problems can emerge. Updates might include new storage drivers to improve compatibility with newer SSDs or NVMe drives. They might modify storage controller behavior to fix bugs or improve performance. They might update firmware for storage devices that support in-band firmware updates. They might change how Windows interacts with storage encryption systems like BitLocker. They might adjust file system drivers, caching behaviors, or power management for storage devices. Each of these changes is intended to improve the system, but each also represents a potential incompatibility or bug that could manifest as storage problems. The types of failures users are reporting with KB5063878 vary in specifics, but share common themes of storage instability. Some users describe their systems failing to boot after installing the update, receiving error messages that the boot device cannot be found, or that operating system files are missing or corrupted. When they access BIOS or UEFI settings, their primary drive isn't detected at all, as if it's been physically disconnected or has completely failed. Other users report that the system boots, but secondary drives, data drives used for storage separate from the operating system drive, have disappeared. Windows no longer sees these drives in File Explorer or disk management, even though they were working perfectly before the update. File system corruption reports describe scenarios where drives are detected, but Windows reports errors requiring disk checks, and running those checks either fails, reports extensive corruption, or completes, but leaves the drive in an unstable state where files are missing or inaccessible. Some users encounter boot loops where Windows starts loading, encounters an error related to storage, attempts automatic repair, fails, and restarts in an endless cycle. The automatic repair process cannot fix whatever storage issue has emerged, but Windows cannot complete boot without resolving it, creating a deadlock that renders the system unusable. The question of whether these are true hardware failures or software-triggered instability is critical. A true hardware failure means the drive itself is physically damaged, sectors are unreadable, components have failed, and the drive will not function properly even if moved to another system or even if Windows is reinstalled. Software-triggered instability means the drive hardware is fine, but Windows is unable to access it correctly due to driver issues, configuration problems, or corruption of software structures like partition tables or file system metadata. True hardware failure requires drive replacement. Software instability can potentially be fixed without replacing the drive. Distinguishing between these scenarios requires technical diagnostics that most users cannot perform easily. Booting from a USB drive with diagnostic tools and in attempting to access the drive from outside Windows can help. If the drive is completely undetectable even from BIOS or from another operating system, that suggests hardware failure. If the drive is detectable, but partitions are corrupted or inaccessible, that suggests software-level corruption. If the drive works fine when connected to another computer or when booting a different operating system like Linux, that strongly suggests Windows-specific issues rather than hardware failure. The mechanism by which Windows updates interact with storage systems is complex and involves multiple layers that all must function correctly for storage to remain stable and accessible. At the lowest level, storage devices communicate with the system through controllers, either built into the motherboard for SATA drives or integrated into the drive itself for NVMe SSDs. These controllers have firmware, software embedded in the hardware that manages communication protocols, error correction, wear leveling for SSDs, and translation between the physical storage medium and the logical interface the operating system sees. Windows communicates with storage controllers through drivers, software components that provide a standard interface between the operating system and specific hardware. Storage drivers translate Windows' generic storage commands into specific commands the controller understands. When Windows updates include new or modified storage drivers, this translation layer changes. And if the new driver has bugs or incompatibilities with specific controller firmware versions, storage access can fail or become unstable. Above the driver layer, Windows implements file systems that organize data on drives into files and folders. NTFS is the standard file system for Windows, handling allocation of disk space, tracking file metadata, managing permissions, and maintaining journaling to protect against corruption. File system drivers in Windows handle all file operations, and updates that modify these drivers can introduce bugs that cause corruption or access failures. Even minor changes to how file system structures are read or written can have significant consequences if those changes interact badly with existing data or edge cases the developers didn't anticipate. Encryption systems add another layer of complexity. BitLocker, Windows built-in drive encryption, encrypts entire volumes and requires keys stored in the TPM module on the motherboard or in password-protected key files to decrypt data during boot. Updates that modify how BitLocker interacts with TPM, how encryption keys are verified, or how encrypted volumes are mounted can potentially break access to encrypted drives. If the update changes encryption-related code in ways that make existing encrypted drives unreadable, users would experience what appears to be drive failure, even though the drive and data are fine, just inaccessible due to encryption problems. Background services that Windows runs constantly also interact with storage in ways that can cause problems if updates modify their behavior. Windows Search continuously indexes files to enable fast searching, reading files in the background, and building databases of file contents. If updates change indexing behavior in ways that cause more aggressive disk access, or that interact badly with certain file types or storage configurations, the increased disk activity could potentially push failing drives over the edge or cause file system corruption through race conditions where multiple processes try to modify the same data simultaneously. Storage power management is another potential source of problems. Windows attempts to save power by spinning down idle drives or putting SSDs into low power states. Updates that change power management policies or timing could cause drives to enter power-saving states at inappropriate times or fail to wake properly from those states. If a drive is in a low power state and Windows tries to access it, but the wake process fails or times out, Windows might incorrectly conclude the drive has failed when really it's just not responding to wake commands properly. Firmware updates delivered through Windows Update represent a particularly risky category of changes. Some storage devices support in-band firmware updates, where Windows can update the drive's firmware directly through software. Microsoft sometimes includes storage firmware updates in Windows updates for drives known to have bugs or security vulnerabilities. But firmware updates are inherently risky operations. If a firmware update fails mid-process, if it installs firmware incompatible with the drive model, or if it introduces new bugs, the drive can become unstable or completely non-functional. And because firmware updates modify the drive's embedded software, the problems they cause can persist even if you roll back the Windows update. The complexity of modern Windows systems makes these kinds of cascading failures more likely and more difficult to diagnose. A modern PC isn't just a computer anymore. It's a collection of interconnected systems, including processors, with multiple security features like virtualization and trusted execution, TPM modules managing encryption keys and secure boot, UEFI firmware replacing traditional BIOS, storage controllers with DMA and advanced features, network adapters with offload capabilities, and an operating system coordinating all of these through layers of drivers, services, and security policies. Each of these components has firmware that gets updated periodically. Each has drivers that Windows manages. Each has configuration stored in registries, UEFI variables, or device-specific storage, and each depends on other components functioning correctly. TPM depends on UEFI. BitLocker depends on TPM. Storage drivers depend on controller firmware. File systems depend on storage drivers. Applications depend on file systems. A problem in any one layer can cause failures that manifest in completely different layers, making diagnosis extremely difficult. Windows Update itself has become more aggressive and autonomous over the years. Windows 10 and 11 install updates automatically for most users, sometimes installing updates during scheduled times, but other times forcing updates when the system decides they're critical enough. Users have limited control over which updates install and when. This automation is intended to keep systems secure and up-to-date without requiring user intervention, but it also means users can wake up to updated systems with new problems they didn't choose to risk. Microsoft's challenge is balancing security, compatibility, and performance across an impossibly diverse hardware ecosystem. Windows runs on countless combinations of processors, motherboards, storage devices, graphics cards, and peripherals from hundreds of manufacturers. Each hardware component has multiple firmware versions. Each manufacturer interprets specifications slightly differently. Each system has different software installed. Creating updates that work correctly across all these configurations is extraordinarily difficult, and it's inevitable that some updates will have problems on some systems even when tested extensively. The testing Microsoft performs before releasing updates is substantial but cannot catch everything. They test on reference hardware configurations, virtual machines, and systems running common software configurations. They deploy updates to Windows Insider preview testers who run pre-release versions and report problems. They use telemetry from millions of systems to identify patterns and issues. But rare hardware configurations, unusual software combinations, or edge cases that only manifest under specific conditions might not appear during testing and only become visible after the update deploys to hundreds of millions of systems. When storage-related issues emerge after an update, determining root cause requires extensive investigation. Is the update code itself buggy? Is it exposing bugs in third-party drivers? Is it incompatible with specific firmware versions? Is it triggering pre-existing but latent hardware problems? Is it interacting badly with specific software? Is it creating race conditions or timing issues that only manifest on certain hardware speeds? Each of these possibilities requires different analysis approaches, and conclusive root cause identification can take days or weeks. So, what should users actually do when faced with reports of KB5063878 causing drive failures? The first and most important step is ensuring you have current backups of all important data. If you don't have backups, create them immediately before installing any updates. Backups should be on separate physical drives, ideally disconnected from the computer when not actively backing up, to protect against both hardware failure and ransomware. Cloud backups provide additional protection against physical damage to your location. The inconvenience of maintaining backups is infinitely smaller than the pain of permanent data loss. Before installing updates, create a system restore point if Windows hasn't created one automatically. Restore points allow rolling back system changes if an update causes problems. Windows usually creates restore points before major updates, but verifying one exists and manually creating an additional one provides extra insurance. Note that restore points protect system files and settings, but not personal data files, which is why backups remain essential. Monitor your drive health using smart monitoring tools. Smart, self-monitoring analysis and reporting technology is built into most modern drives and tracks various health metrics like reallocated sectors, pending sectors, temperature, power on hours, and error rates. Tools like Crystal Disk Info can read smart data and provide health assessments. If Smart indicates your drive is failing or has warnings, you should replace it regardless of update issues because it's at risk of imminent failure. If Smart shows your drive is healthy and an update causes problems, that suggests software issues rather than hardware failure. If you haven't yet installed KB506878 and you're seeing widespread reports of issues, consider pausing updates temporarily while waiting for more information. Windows 11 allows pausing updates for up to 5 weeks in settings under Windows Update. This gives time for reports to clarify whether issues are widespread or isolated, for Microsoft to investigate and potentially pull the update or release a fix, and for more detailed technical analysis to emerge. Pausing isn't without risk since you miss security patches, but if the update poses storage risks, temporary delay might be prudent. If you've already installed KB506878 and are experiencing storage issues, first determine whether your drives are detectable. Access BIOS or UEFI settings during boot and check whether drives appear in the drive list. If drives are completely missing from BIOS, that suggests hardware failure or controller problems rather than Windows-specific issues. If drives appear in BIOS but Windows can't access them, that suggests driver or file system problems. For boot failures, attempt Windows automatic repair by forcing the system to boot into recovery mode, usually accomplished by interrupting boot several times until recovery mode triggers. From recovery mode, you can try system restore to roll back to before the update, startup repair to fix boot-related problems, or command prompt to run disk checks and repair commands manually. If you cannot access recovery mode because the system cannot find the boot drive, you'll need bootable USB media with Windows installation files to access recovery tools. For disappeared secondary drives, check disk management in Windows to see if drives appear as unallocated or without drive letters. Sometimes updates cause drive letters to be removed, and simply reassigning letters makes drives accessible again. If drives don't appear in disk management at all but appear in BIOS, driver issues are likely, and rolling back the update or reinstalling storage drivers might help. Running disk checks can identify and sometimes repair file system corruption. The command line tool itscask can scan drives and attempt repairs, though it should be used carefully as it can sometimes worsen corruption if drives are failing. For drives with suspected hardware problems, data recovery should take priority over repair attempts that might further damage the drive. Rolling back, KB506878 is possible within 10 days of installation by accessing Settings, Windows Update, Update History, and selecting Uninstall Updates. After 10 days, Windows deletes the rollback files to free up disk space, making rollback impossible without full system restore from backups. If the update caused problems and you can successfully roll it back, report the issue through Windows Feedback Hub with as much detail as possible about your hardware configuration, symptoms experienced, and diagnostic results. User reports help Microsoft identify patterns and develop fixes. Checking for firmware updates for your storage devices and motherboard might help if compatibility issues are involved. Manufacturers sometimes release firmware updates to address problems with specific Windows versions. However, firmware updates carry their own risks and should only be installed if you understand the process and risks, or if manufacturer support specifically recommends updating to resolve known issues. If you determine your drive is genuinely failing rather than experiencing software issues, immediate data recovery becomes critical. Stop using the drive as much as possible to prevent further damage. If the drive is still somewhat accessible, copy critical data to another storage device immediately. If data is inaccessible but extremely important, professional data recovery services can sometimes recover data from failed drives, though this is expensive and not always successful. The broader implication of incidents like KB506878 and storage failures is that modern operating systems have become so deeply integrated with hardware that the boundary between software and hardware problems is blurred. A software update can expose hardware weakness, accelerate hardware failure, or create symptoms indistinguishable from hardware failure even when hardware is fine. The reliability of your system depends not just on hardware quality or software quality independently, but on the complex interaction between them. This complexity means that even routine updates now carry consequences that weren't present in simpler computing eras. Updating your operating system isn't just changing software anymore. It's potentially changing how your hardware functions, how firmware behaves, how components interact. Each update is a systems-wide change that could affect anything from boot processes to encryption to storage access to power management. And because these systems are so interconnected, problems in one area cascade unpredictably. Microsoft's position is difficult because they must continuously patch security vulnerabilities, fix bugs, and improve performance, but every change risks introducing new problems on some subset of the vast hardware ecosystem Windows supports. They cannot test every possible configuration. They cannot predict every edge case. They cannot satisfy competing demands for aggressive security patching, perfect stability, and support for ancient hardware simultaneously. They do what they can with the constraints they face, but the result is that updates sometimes cause problems, and storage-related problems are among the most serious. The trend toward complexity shows no signs of reversing. Future Windows versions will likely have more cloud integration, more security features, more background services, more interconnected components. Storage systems will become more sophisticated with new technologies, like persistent memory, computational storage, and disaggregated storage. The complexity that makes KB5063878's storage issues possible will only increase, meaning the potential for update-related problems will persist and possibly worsen. Users are left navigating this complexity with limited information and limited control. You cannot avoid updates indefinitely because security patches are necessary. You cannot avoid complexity because modern computing requires it for the features and capabilities we've come to expect. You cannot perfectly prevent hardware failures or software incompatibilities because you don't control the code or the hardware designs. All you can do is take reasonable precautions, maintain backups, stay informed about reported issues, and respond appropriately when problems occur. The KB50638 storage failure reports, whether they ultimately prove to be widespread issues requiring urgent action or isolated incidents affecting rare configurations, illustrate the fragility hiding beneath familiar interfaces. Your desktop looks the same after each update. Your files are where you left them. Your applications work as expected. Everything appears stable and reliable. But underneath, extraordinarily complex processes are running, coordinating countless components, managing sophisticated interactions, and maintaining the illusion of simplicity. When that illusion breaks, when an update triggers drive failures or boot loops or data corruption, we're suddenly confronted with the reality that modern computing is a precarious stack of abstractions, any of which can fail and bring down the entire structure. We trust our data to storage devices that could fail at any moment. We trust our access to that data to software that could corrupt it through bugs. We trust our systems to updates that could break what was working. And we have limited ability to prevent or even fully understand these failures because the systems have become too complex for any individual to completely comprehend. This is modern computing, powerful, capable, feature-rich, and fragile in ways that aren't apparent until something breaks. KB5063878 might be the update that breaks drives this month. Next month, it will be a different update with different problems. The specific incident changes. The underlying reality remains. We're dependent on systems too complex to be perfectly reliable, updated continuously to address endless security threats, running on hardware that will eventually fail. We manage these risks as best we can with backups, monitoring, caution, and hope. And when failures occur, despite our precautions, we recover what we can, fix what's broken, and continue trusting systems that have proven themselves untrustworthy. Because we have no viable alternative in a world that runs on computing. The drive failures reported after KB5063878 are symptoms of this deeper fragility, reminders that the reliability we assume is always provisional, always dependent on countless components functioning correctly, always one bad update away from catastrophic failure. That's the truth hiding behind routine update notifications. That's what makes reports of storage failures urgent rather than merely inconvenient. And that's what we must accept, to participate in modern computing. The certainty that eventually something will break, and the uncertainty of when and how severe that break will be.